Hi everybody, welcome to ShoutingElectronics. It is 6:30 in the morning on Friday the 3rd of April 2020. We are at the beginning of day 8 of South Africa's national lockdown against the coronavirus. I wasn't planning on mentioning anything on my channel about coronavirus because everybody and their dog is talking about it in every blog post and website and everything you can see. But I've noticed a trend coming on Facebook and Twitter and everything where people are trying to link coronavirus and its effects to the 5G installations that's been going on recently in the past couple of months, basically. So I thought, let me just, because I'm an electronics engineer hobbyist and dabble in things like that, I thought, let me just give you some more details about 5G, what it is, how it works, just so you can be more informed and then just to enlighten you. So I'm hoping this video is not going to be long. I'm hoping it's going to be informative and that you can learn something and that you can make your own choices. Okay, so what is 5G? Okay, you know your cell phone with your existing LTE internet and your 4G and things like that. 5G is just the next step up, basically. It gives us faster speeds, lets us use more devices and things like that. Because everyone's on Facebook and YouTube and things like that, so the internet needs more speed, basically. So 5G is the next step up where it can give us a lot more speed. If you look at this graph, it shows you exactly how much speed 5G gives us, a speed boost compared to the existing LTE. It basically lets you download high definition movies in seconds. Okay, and lots of people at your house can share the same connection without it bogging down because there's just enough speed for everyone. Okay, are there any safety limits to it? Who defines the safety limits for it? You've got a company called the IRP, the ICNIRP, the International Commission on Non-Ionizing Radiation Protection. They've done these studies and they've decided what safe levels are and things like that. So basically they're the ones that set the limits and say, okay, beyond this point, people can get injured by the radiation. And the World Health Organization works together with them to make sure that that gets implemented, okay? And the FCC. Any device that transmits power in America, and that has to be designed and tested by the FCC to make sure it's reaching the right frequencies, not giving out the wrong frequencies, too much exposure and things like that. So all three of these companies have to agree on exposure limits and levels and things like that. Okay, now how much radiation, or how much RF, hope you can read that there, are we exposed to from a 5G installation? Okay, you've got a few different ones. You've got the little base stations. It looks sort of like Wi-Fi routers and that gets put into the schools and office parks and things. That's a nano station or a mini station or whatever. That's 250 milliwatts right at the station, okay? Now you've got an inverse square law, which means every time you double the distance from the station to yourself, you're actually getting 1/4 of the exposure. So if we say 250 milliwatts, let's say that's 1 meter away from the station, okay? Then at 2 meters away, it's going to be 1/4 of 250. And you guys can work out 1/4 of 250 for yourself there. But eventually, let's say you go 10 meters away from that antenna there that's leaving 250 milliwatts. After that 10 meters, you're getting exposed to 8 watts. A microwatt is a millionth of a watt. So at the distance of 10 meters, you're getting exposed to 8 millionth of a watt. Now your normal light bulb in your house is, well, the older type was 60 watts, and you know that generates a lot of heat. 8 microwatts can't do much heat at all, basically, so it shouldn't be able to do damage to your cells and things like that. Now you say, okay, but what about the stations on top of the towers and on top of the buildings and that? So let's say you got a tower here. Okay, there's your tower with its aerials pointing. How high is the tower typically? It's normally about 30 meters, okay? These towers are around about 20 watts transmission power. Okay, the closest at the ground level you can get to that antenna is 30 meters away. At 30 meters, because of that inverse square law, you're getting less than 1 microwatt of exposure, less than 1/1,000,000th of a watt. So that's even less than the microstations that they're putting in the buildings and that. Now, you say, what if they mount the antenna on the building? Aren't you getting exposed if you're inside the building? Okay, so here's your building. Okay, say they mount the antenna on top of the building there, and one there. They don't want to waste energy sending signal where there's going to be no phones. So they're not going to send signal all the way around in a normal circle. They're just going to send about 120 degrees out that way, and down like this, up like that, because they don't want to waste energy, basically, because nobody's in the sky with a cell phone, and it's no use pointing straight down through the building because the signal's going to get cut by all the floors in the building. So the ones on the building are pointing away. If they mount the antenna on the side of the building, also it's set to radiate out that way, not radiate back into the building. So these people in this building, they won't get signal from that cell phone tower. They'll actually get signal from a tower on another building that's got antennas facing towards them. And then remember that inverse square law. So if you're 30 meters away from that other building, less than 1 microwatt. If you're more, say you're 60 meters away from that other building, 0.5 microwatts. So that's very little power, basically. Okay, but now what about the phone you're putting up to your ear? Say you take this phone. Okay, I don't know if you can see, it's got a picture of a cat on it, and you're holding it up against your ear. Earlier phones could have put up to 2 watts out.
Smart man would. That's a big ass phone. Don't put that up to your head. Hey, you know?
Now that phone looks like it could have done a lot more than 2 watts. Okay, but anyway, the earlier phones, those old Nokias, and they could do up to 2 watts if they need it. But with the 5G, if you're in an area with a decent signal, your phone will put out less than 1 microwatt. If you get a bit further away, maybe it'll go up to 1.5 microwatts or 2 microwatts, but still that's very little. Now coming on to that, does 5G always push out the maximum power? So will this tower always give out 1 microwatt or 20 watts, which goes to 1 microwatt at the ground? Will your phone always give out that 1 microwatt? No, it doesn't need to. The 5G and all the previous cell phone systems were designed to lower the power levels, basically. It's no use having your tower over here. I'm not an artist, my wife's the artist. Okay, and you have a tower over here, you have a phone over here. They can talk to each other because they're quite close. Why have this one shout at that one and make this one shout at that one? Because that just creates a lot of noise. It's a lot of unneeded radiation and things like that. So the tower, when it talks to the phone, it does a negotiation, and it says, I don't need so much power, you're shouting at me, turn your power down to a reasonable level. So that's what it does. The tower chokes it down to whatever it needs, the phone chokes it down. Advantage of that is you get less power usage by both devices, and you get less radiation. Okay, and your battery life improves. Don't know if you've been in an area with poor performance, poor cell phone signal, and you notice, yo, my battery's only lasting a few hours. Then other places, oh, my battery's lasting a day and a half. That's because in the poor signal area, your cell phone has to push its transmit power up to talk properly to the tower. In a good signal area, it turns it down, saving the battery power, giving out less radiation. This existed before 5G. This was with 4G, 3G, 2G, but they've improved their methods and they actually need a lot less power to do the same thing with 5G. Also, with 5G replacing existing systems, they're busy phasing out 2G and 3G. They're sticking with 4G and LTE. Once 5G is in place here, they're going to be switching off the 2G and the 3G transmitters, and maybe in 10 years they're going to start switching off the 4G transmitters. Then all that extra radiation from those older, uneconomic, inefficient transmitters, that radiation is going to go, and then you're going to be stuck with this lower, more efficient 5G signal. Okay, then now what do you say? Okay, 5G is using higher frequencies than 4G. Okay, let's go with that there. Okay, your existing cell phones, your 2G, your 3G and that, they use 900 megahertz, 1800 megahertz, and 2.4 gigahertz, okay, which is also your Wi-Fi. And hello cat. Now, and your microwave ovens, okay, also use the 2.4 gig, because 2.4 gig works well to vibrate the water molecules and to make them hotter. That's why your microwave oven uses this. But your microwave oven is 1500 watts, basically at that frequency. Okay, now let's see the planned frequencies for 5G are between 3.4 gigahertz and 4.2 gigahertz. Now if you look at this chart, this shows how deep into the body different radio frequencies penetrate, okay? If you look at this chart, this shows how deep into the body different radio frequencies penetrate, okay? If you look at this chart, look at the 918 to 2.4 gigs, round about there. If you look at the 3.4 to 4.2 gigahertz range, it's penetrating a lot less into you. In fact, your skin is actually a very good barrier against the higher frequencies radio waves. Now there's another question. Base stations are going up everywhere. On towers, on the side of buildings that we saw there, even on the street lights. So you got a street here, you got your, I'm not the artist. Okay, so they got street lights. They're actually putting antennas on top of, say, every second or third street light. Why are they doing that? Why don't they just have one big one for the area? Then it's causing more radiation and things like that, having so many dotted all around in buildings and things like that. Let's go outside for this one so I can show you why they do it like this. Okay, the next thing we're going to address is why do they need so many 5G base stations where your normal cell phone, your 4G, your LTE and that, used a cell phone tower up on a mountain and things like that. Whereas with the 5G, they seem to be putting it on every second or third street light, on a few buildings, or putting them inside buildings for coverage inside. So basically, I'm going to address that now by showing you an example as best I can. Okay, say this is the person with a cell phone, okay, that's connected to a cell phone tower, okay. Now with 5G, because it's a higher frequency, some cases it's got more losses, so normally you got two options. You can either boost the power to overcome the losses, or you can reduce the distance. Let me show you what happens with that, okay? So that's a cell phone in the person's hand over there, and I am the cell phone tower down here. Hope you can see me in the bushes. Oh, let me circle myself there. Okay, so I'm the cell phone tower. Hi, cell phone. I'm tower. Can't hear you. Speak up. Cell phone. I'm the tower. Yes, tower. What'd you say? Can you hear me? Okay, I can hear you now. Can you hear me? Ah, okay. Now I can hear you. Okay. So as you can see, the tower has to shout and give a very strong signal to reach the cell phone all the way on that side. Okay, so the cell phone also has to shout back to the tower so they can hear each other. So that's basically the dilemma. They have to shout at each other because it's such a long distance, and when that happens, you're using a lot of battery power. Maybe I should come closer and say that. So basically what you saw there is, because it's such a long distance, even if I want to talk to somebody on the other side, I need to shout or else they can't hear me properly. And when your cell phone is shouting, it's using a lot more power to send the signal, so it's making your battery drain faster, and it's trying its best, so it's giving out a lot of radiation that to try get the connection proper. Okay, but the thing with these 5G towers, instead of wanting to boost the power a lot more than the 4G towers are, they said, let's reduce the distance. Let's put cell phone towers all over. So let's see how that one works with reduced distance now. Okay, so once again, I am the cell phone, and I'm the tower that's less distance. It's a lot closer because there's more towers all over. Okay, so I'm the tower. Hello, I'm tower, calling the cell phone. Any cell phones out there? Hi tower, can you hear me? Oh, good. I can hear you nice and clearly, cell phone. Maybe a bit too loud. Maybe just turn down your power a bit more. Okay, now I'll turn it down a bit. How's that? Is that better? Okay, that's perfect. Okay, let's keep it like that. That way we're saving battery power and we got a good connection. Okay, perfect. Let's carry on with the call. So as you can see, by having the tower closer to the cell phone, you reduce your need for a stronger signal. You make your battery life longer. It gives out less radiation on the tower side and on the phone side. So that's why they put towers every few streetlights, so it gives you a good connection, needs less power, gives out less radiation. Also, when you get walls in the picture, say between our points there, we got a wall. That even cuts the signal down even more. So that's why they put the repeaters and that inside buildings as well, on every floor, every second floor, whatever, so that they don't need to push so much power to make it all the way through the wall. It's just common sense. Save battery power, use less energy, give out less radiation, and it's a win-win. It does cost a bit more for hardware, having to put towers everywhere or base stations everywhere and having to supply power to them and that, so it draws a bit more electricity, but it requires less to connect to the phone, basically less RF energy. More electrical energy in, but it's using less RF energy for the whole system. So I hope that explains that point. Okay, well, we're back inside now. There's just 2 points that aren't too technically minded about how 5G works compared to previous technologies. What's relevant at this time, specifically because of the lockdown and that, is coronavirus or CONV-19 or whatever it is. It's got a few different names. They're saying, okay, that this virus originated from China. Biologists and scientists have confirmed that this virus jumps from animals to humans. They say there's no way radiation could actually have caused this. But also, if you look, 5G was implemented in China in the end of October 2019. But South Korea actually started using it properly in April last year. Okay, in April 2019. And they've been trialing it since 2017. So if Korea's been using it for longer, shouldn't they have seen this? And shouldn't they have been the first ones affected by 5G? Or if 5G causes coronavirus, shouldn't they have been the ones that first exposed and things like that, instead of it originating from China? Okay. And a lot of other countries have also been experimenting, so they should have also seen symptoms and seen, if it was coronavirus related, they would have seen it before the time. It wouldn't have just appeared now magically from China. Okay. And then just the last point here. I'm trying to keep this short for you. The planned inoculations contain a tracking microchip, and government will use this and the 5G system to track you. Okay, I don't know how many of you have pets. I'm running out of paper here. They say if you've got a pet, you must always have a collar on it, or you must get a microchip embedded in it. Okay? The microchip is basically a coil of wire connected to a microchip or an integrated circuit there. Okay? That's basically it. A coil and a chip. When the coil receives power, the chip replies and sends out its number out that coil back to whatever's busy sending it power. Okay? Now for the pets, you actually get it in a little grain of rice. Well, it looks like a grain of rice. It's a small thing like this. It's got the coil. It's got the little chip there. Let's see if I can get a photo from YouTube for you. Okay, so if you see there, you can see the antenna and you can see the little chip. And when you want to scan a dog or a cat to see if it's got the chip with that big scanning probe or whatever, you need to get within less than a centimeter. You basically have to rub it on the animal's skin to pick up the signal from that chip. Okay? Let's take it a step further. Your bank card. No, you had your previous bank cards with a stripe, the mag stripe, that they've discontinued in that, and then you had that little chip on it, like a smart card type thing. But then the next evolution was, you get the ones like that still, but inside it, your normal credit card and things like that, and some forms of ID. It's got a little chip, okay, exactly the same, and then it's got a coil going around there. Goes around a few times and back there. Remember, none of these have batteries in them. They're relying on power coming from the scanning device, pushing power in here enough to get the chip to work, and then the chip goes and talks back through that coil. So you need a lot of power to send a signal far. So the dog chip, we said, at most 1 centimeter, okay? Your bank card, I don't know if you've tried to tap it, I think 1.5 centimeters is what I've got on the normal bank machines, okay? Now let's go and anti-theft at your shops, okay? You walk into the shop, you go past these things that look like metal detectors. It's got the little light on top and that. And if you walk out and you haven't paid for an item, or they haven't cleared an item that you paid for, those lights are flashing in that. How does that work? Also the same thing. Well, there's a few different systems, but the newer system, under the item or in the box, you'll see there's a sticker. Normally the barcode sticker or whatever. It's got a chip and it's got the coil. So this has to go through those things. If it's not deactivated or whatever, then those things will sense it and they'll set the alarm off. These things, to power that chip to get the signal, they have to be sending out power between them there to charge that up. Now that needs a lot of power because you're picking up over a distance of what, about a foot on each side. So at least one foot you need, say, half a watt of power or things like that, just to scan this thing that's actually, let's say it's about a 5 centimeter square chip with a coil in there that's stuck on. So you need so much power in such a little space to be able to scan it just at a foot or 2 feet or 1.5 centimeters. So for the 5G to run a chip and to talk to tracking chips and things like that, you're going to be needing to pump watts and watts out, as much more power than this is giving out, which just isn't feasible based on the power usage in that. You saw there, over here, 1 microwatt we're getting at the ground level from the tower, and 8 microwatts from a mini base station. It's not enough power to charge up this coil and to charge up the chip that's in there. And then it still has to listen for the very faint signal from this thing coming back. Basically, at the moment, it's not feasible, the amount of power that you're going to need to be able to run all these tracking chips from 5G towers. Okay, thank you for watching this video. I hope you have learned something about 5G and the technologies that have come out and are being implemented. I hope it helps allay or allay or whatever some of your fears and that, and just will help you make more informed decisions. I hope you learned something. Thanks. And also, if you enjoyed this video, please give it a thumbs up. If you want to, you can subscribe and click that little bell icon, and then you'll know when we put more videos up. Thank you.